And it consists of a programmable microcontroller board and an integrated development environment, that is IDE, for writing and uploading codes. Uh, you can connect the Arduino device to your laptop or desktop computers, and you can uh, easily code the Arduino based on your requirement. It is kind of easy to use hardware and software make Arduino ideal for prototyping IoT devices. And Ardu- Arduino and IoT, like what is the connection between them? Arduino serves as the brain of IoT devices, collecting sensor data and controlling actuators, and so on. And it enables interfacing with various sensors like temperature monitor sensor, humidity, motion, and etc. sensors, and communication modules like Wi-Fi, Bluetooth, and LoRa for connectivity devices. And connectivity of the devices. And data collected can be sent to the cloud services or local networks for analysis and monitoring. And the programming basis in the Arduino, you can use C++ coding using the Arduino IDE interface. And two main functions in Arduino sketches like setup runs once for initialization, example setting pin modes, starting serial communications, etc. And loops runs repeatedly the core logic of the program, example reading sensors and sending data, etc. And common programming constructs are like digital and analog input output operations, that is digital read off, and another one is digital write off, and for the digital ones, and read and write commands. And for analog read and write commands, that is analog read off, and with analog write-off, using libraries to interface with sensors and modules, and serial communications via serial.begin off and serial.print for debugging and data transmission, working with sensors and actuators, reading sensor data, temperature, gas proximity, controlling actuators like LEDs, motors, relays. Example, controlling LED based on sensor threshold value, interfacing communication modules, Wi-Fi modules, ESP8266 and ESP32 for internet connectivity, uh, Bluetooth modules for local device communications, sending sensor data to IoT platforms like Things Board, Blink, AWS IoT using protocols like MQTT or HTTP. And programming workflow, connect Arduino to PC via USB, write code in Arduino IDE, and verify and upload the code to the Arduino board. Use serial monitor to view data and debug. And example sketch, LED blink, CPP, and void setup of, and pin mode LED built in and output, and void loop digital write of LED underscore built in, and high turn LED on delay of 1000. That is a delay thing. So in this, this is for this particular code is for LED blink, as you can see, and it is C++ code. That is what the CPP is, and the main code is beginning from here. The void setup functions, and in this pin mode LED built-in output. So this will give the output of whether to turn on the LED light, blink, or something like that. And in this function, it will write the digital write command, LED built-in high means on, and turns on LED. And how much minute it should wait. Like delay is 1000 seconds. So wait is 1 second. It is all microseconds. So 1 second is equal to uh, close to 100 microseconds. And digital write, that is LED built-in low, so this will turn off the LEDs, and the delay is wait is 1 seconds. So best practices, modularize code using functions for scalability, hand errors and exceptions properly, example sensor disconnections, and optimize power consumption for battery powered IoT devices, secure communication using encryption protocols. And these are the best practices of the Arduino programming using Arduino. And C++ programming is a general programming, and what kind of task you are going to use it, you are going to perform the actions based on that. You'll be writing the codes. Um, that's it for the programming with Arduino in IoT. Next topic is programming with Raspberry Pi. Uh, in programming with Raspberry Pi, like what is Raspberry Pi? Raspberry Pi is a compact, affordable single board computer widely used in IoT projects. Compared to microcontrollers like Arduino, it offers full operating systems. Commonly, Linux based operating systems is used on board and supports higher level programming languages. Its GPIO pins allow interfacing with sensors, actuators, and communication modules. And Raspberry Pi versus Arduino in IoT, like Raspberry Pi can handle complex computing tasks, networking, and multitasking because it has a onboard computer uh, in it, suitable for applications requiring image processing, data logging, or running web servers normally used in CCTVs example. And Arduino excels in real-time control and low-power scenarios. And programming languages and environment. It also it can we can use multiple programming languages. Supports multiple languages like Python, most popular in IoTs, C, C++, and Java and Node.js. Those are the popular applications supported in this. Arduino, the Raspberry Pi. And the Python libraries are GPIO 0 and RPI .gpio for hardware controls can run full software stacks or databases and web services. So that is one advantage of this particular thing. And common IoT programming concepts on Raspberry Pi is like GPIO programming, reading inputs and controlling outputs via pins, and sensor integration is connecting temperature, humidity, motion sensor, etc. And communications, these use Wi-Fi, Ethernet, Bluetooth modules for connectivity, and protocols used are MQTT, HTTP, and COAP to communicate with IoT platforms and cloud. And typical programming workflow: set up Raspberry Pi OS, Raspbian, and connect to network. Write and test code um, locally using editors or remote IDEs, and interface with hardware through GPIO pins, and send or receive data with cloud services or other devices. So this is an example Python code snippet for blinking an LED. So you have to import this particular library rpi.gpio as GPIO import time. So you have to import this library, time library. LED underscore pin is equal to 18, and GPIO dot set mode, GPIO dot BCM, and this will set the mode, what kind of activity it is going to happen. And GPIO setup is something like the LED, how the LED should function, or it will start that particular setup function will start that operation. And so how it is in a try except loop and while loop. So while two GPIO output LED pin GPIO high means it will turn on the uh, LED link, LED light to blink, and time span is for 1 second approximately. And so when you have the GPIO dot output LED pin, GPIO dot low, it means it turn off the LED light, and except keyboard interrupts or GPIO dot cleanup commands. And again, the best practices: use virtual environments for Python packages, and manage power usage for battery operated devices, secure communications, and update software regularly. And use version control, example Git, for project management and applications, home automation, smart surveillance, and environmental monitoring, edge computing tasks in IoT deployments. And that's the end of module